let's talk about solving rational equations. The word rational means fractional. So since we're talking about fractions, we need to consider the denominator. If you recall, the denominator is the bottom of a fraction, and you've always been taught that a denominator is undefined when it's equal to 0. So in all of these equations, before we solve them, we must find any number that causes that denominator to be 0. These we will call the restrictions. So whenever you are asked to find the numbers which cause 0 denominators, those are called the restrictions. In this first example, we want to find what are the restricted values. So look at 2x. What would x need to be to multiply by 2 to make that be a 0 denominator? The only number you can multiply by to give you a 0 is 0 itself. So 2 times 0 is 0, and we don't want that. 18 is a constant. It would never equal 0. 3x is real similar to the first term because 3 times 0 would make that 0. No other number gives you 0. So basically, when you have a single term monomial on the denominator, that means your restricted value is 0. So we say that x cannot equal 0. Even if we solve this and we get the answer of 0, we cannot use it because that would make the original problem undefined. Now, let's go about solving. If you recall covering with me the steps to solving an equation, the first step is to normally eliminate the fractions with the least common denominator. So, what number would a 2, an 18, and a 3 all divide into? That's right, an 18. 18 is divisible by 2, 18 is divisible by 18, and 18 is divisible by 3. So let's go ahead and say our least common denominator is an 18 along with the value x, since there is an x in the denominator. What I will do is I will put 18x beside each term in this equation. That's my least common denominator. I will not keep it though. I'm going to use that common denominator to cancel out. So 18x divided by 2x leaves 9. That is left there along with the 5 from the top, the numerator. Bring down the equals. In the second fraction, the 18 cancels out, and that leaves the 17 along with that x. Notice the second x did not cancel here like the first one did. And last but not least, in the third fraction, the x's cancel, but 18 divided by 3 is 6. And that leaves my negative 1 times that 6. Now, do you notice all the fractions are gone? Now let's see what we have. 9 times 5 would be 45. 17 times x is simply that, 17x. And negative 1 times 6 is a minus 6. We must now solve for x. So I'm going to move the negative 6 over. Remember, you change the sign. Use the opposite sign when you move that term over. 45 plus 6 is 51. And remember, the last step is always to divide by the coefficient. The coefficient is the number in front of the x. So let's see what we get. 51 divided by 17 ends up being 3. My solution is 3. And that is how you solve the first rational equation. What if, in this second example, I have binomials in the fraction denominator? What would make this x minus 2 equal to 0? Well, that would be 2. Think about it. If I had x minus 2 equals 0, I want to know what makes that true. I would just move that over, add 2, x has to be 2. That is my restricted value here. So I put x cannot equal to 2. That's my restriction. All right, that's just off to the side. Now, what is my least common denominator? Well, it's got to have x minus 2 in it. And notice I had a 3. Now, there's no way 3 can turn into a 0, so you don't have to worry about that. But 3 has to be part of the least common denominator. I'm going to say the least common denominator is 3, and then use a parentheses, x minus 2. Write it like that. So I'm going to put 3x minus 2 beside each one of these, of these fractions. Okay, 3x minus 2, 3x minus 2. Kind of squeezing it in here. All right, with the first one, the x minus 2 cancels, and it leaves me the 3 and the x. Bring down the equals. With the second fraction, the x minus 2 cancels, and that left a 3 and a 2 from the original fraction. Bring down the subtraction. In the last fraction, only the 3 cancels, so that leaves me my 2 and my x minus 2. So let's see what we have. 3 times x is 3x. 3 times 2 is 6. Use the distributive property on the back here, and I get negative 2x plus 4. Notice I have some like terms to combine on the same side. 6 and 4 give me 10. Then I need to move my 2x over, change the sign, it becomes positive. That's 5x equals 10. Then I divide by 5, the coefficient, and x equals 2. Yay! I have the solution. At least that's what I think I have. Notice that this solution and this restriction are the same. If that ever happens, you have a no solution inconsistent, because the solution cannot be that restricted value. Therefore, this is one with no solution, even though it appears as if it does have one. Good luck on these.